Have you ever had a coding nightmare? An issue so insidious that it kept you up at night? And worst of all, you only have yourself to blame because you were the only one who touched the code? Today I'd like to talk about the importance of clean coding, both scientifically and aesthetically. And to do that, I want to rely on a couple of different resources. One is Robert Martin's book, The Clean Coder, and the other is a coding guide by renowned economists Matt Gentzkow and Shapiro. And if we think of what clean code is, it has three characteristics. First, it's easy to understand. Second, it's easy to modify without introducing bugs. And third, it's easy to debug, meaning to make the code work when it was not working before. Let's go through an example of what clean coding might look like. Here, I have an R script that has two different ways of creating a data frame. On the top part of the file, we see that the data frame is created manually, where we name the columns and insert the contents of the columns all in one line. The better way to do this is to create a custom function that takes as an input the number of observations and the variable names, as this is more easily understood by the user. And if we need to adjust how this data is made, we can do that inside this custom function in a structured way, and then we can call this function however many times or however many places we need to accomplish what we want. Clean code is not just a way to keep nightmares away from yourself, it's also really important for science. Science is based on replication and verification of past results. If prior results are not replicable or not verifiable because of poor coding practices, that undermines the scientific endeavor. So why isn't clean code the norm? Why do we even need to make a video about how to write clean code in the first place? There's three reasons that clean code is underproduced. First, there's competitive pressure. As a scientist, the goal is to publish research, to get that research cited, and so there's not really any credit given to writing clean code. A related issue is number two, which is that the end user doesn't see the code and doesn't particularly care what the code looks like. In science, the end user is a peer reviewer or a fellow scientist, and they don't particularly care if you did your regression estimation in Fortran or Stata or Python. They just want it to be correct. Third is short-term thinking. So what we mean by that, there's not an incentive in the moment to create the clean code that we're after. And in the moment, it feels like it would take more work to create the code than it actually would. And we don't really internalize the benefits that accrue over the long run when paying that cost to write the code extra clean in the moment. So that's a little bit of an intro to clean code. In this set of videos, we'll cover different ways that we can make our code cleaner. And the next video will be about how to automate our processes.